Hi everybody! Today we're going to get started on some exponential and logarithmic word problems. So some useful formulas at the top. We have some exponential growth and decay formulas. So this one here, you could have a plus or a minus depending on if it's growth or decay. We have a sub 0, that's our initial amount. So however many things or dollars that we're putting in at the starting time. Then for my exponential function over here, we'll have one either plus my rate or minus my rate. And then that's to the t. Over here, this base and this k are labeled over here. So k is the time needed to multiply that initial amount by b. So if I say something like I'm doubling the amount in 5 days, my base would be 2 because it's double, and my k would be 5 because it's 5 days. Or I could quadruple in 2 years, and then in that case, my base would be 4 and the k would be 2. So if we take a look at this first example, so suppose the cost of a hamburger has been increasing at a rate of 9% per year. So my rate is 0.09. So each year the cost is 1.09 times the cost of the previous year. Suppose today that a hamburger costs $4. That's my initial amount. How much will it cost to buy a hamburger in 3 years or in 10 years? So initially, my function, we have my initial amount for 1 plus 0.09 gives me 1.09 to the t. So to find the amount in 3 years, I'm going to just have to plug in 3 for t and plug that into my calculator. So that'd be 518 in 3 years, and then in 10 years, we plug that into the calculator and we get 9.47. So this is money, so obviously round to the nearest cent. If I ask for a past time, then we plug in a negative number. So in this next example, it's all the same information, but I'm asking you how much did it cost to buy a hamburger 3 years ago, and then I ask in how many years will it cost $4.50. So 3 years ago would be a of negative 3. So that's 4 times 1.09 to the negative 3. So it should be less than my initial amount since the cost is increasing. And we get $3.09 3 years ago. Okay, so now it says, in how many years will it cost $4.50? So that is going to be a value that we plug in for a of t. So 4 of 50 equals 4 times 1.09 to the t. So I'm going to divide both sides by 4. So we get 4.5 over 4 equals 1.09 to the t. So to finish solving this one, I'm going to have to take the common log of both sides. And I'm going to want to write this in a calculator ready form. So we have the log of 4.5 over 4 equals, and I can take my exponent and bring it out in front, so it's t log of 1.09. So now I can divide by log of 1.09, and my calculator ready answer is a log of 4.5 over 4 divided by the log of 1.09. So I want to see that calculator ready answer before you plug it into the calculator, and we'll just round to the hundredths. So in 1.37 years, it will cost $4.50. The next example, we have a bank advertises that you can double your money in 12 years. So that one, we're going to use that A of t equals a sub 0 b to the t over k formula to start. We want to express it in both forms, but I'm going to start with that one. So we're doubling our initial amount. I don't know what the initial amount is, so I'm just going to keep it as a sub 0. My base is going to be 2 because it's doubling in 12 years, so k is 12. So that's my first form. Now to get it into my other form, I'm going to just do some manipulation here. So I'm going to change this to 2 to the 1/12 to the t, right? That is equivalent, right? Because a power to a power here, I would multiply those to get back the t over 12. Then I'm just going to plug that piece into the calculator, and I'll round it 4 decimal places. So we get a of t equals a sub 0, and then that will give me the 2 to the 1/12 is 1.0595 to the t. If I wanted to find my growth rate, right, based off of the fact that this is corresponding with a sub 0, 1 plus r to the t, that means that 1.0595 is equal to 1 plus r, so my rate is 0.0595, and as a percentage, it would be 5.95%. So I didn't ask for that piece, but it's just something, an extra piece of information I can pull out of that form. The next one is similar. We have a half-life of 5 days. So that is telling me that my base is 1/2 and my k is 5. So we're asked to find at what rate does the substance decay each day. So I'm going to take this and put it in my other form by doing 1/2 to the 1/5 in my calculator. So that gives me 0.8706 to the t. Remember, this corresponds with 1 minus r. So 0.8706 equals 1 minus r. So my rate is 1 minus 0.8706, which is 0.1294. And as a percentage, that's 12.94%. The next type we have here involves some of our natural base. So we have here, first is the definition of E. We sort of talked about this a little bit already. We'll define it more specifically or find it when we get to limits, but this is actually the exact value of E. And we're going to end up using our these two formulas for mainly interest problems. So this here is compound interest, and it says we're investing an initial amount, a sub 0. We have 1 plus, this is my rate, divided by the number of times my interest is compounded that year to the nt. So n meaning the number of times it's compounded, that just means the number of times you earn interest per year. So, for example, if it's semi-annually, n would be 2 here and here. Then this example here is continuously compounded interest. So this is if I'm always making interest based off of my investment. So we have my initial amount times e to my rate times t. So these are, a little bit different than a normal exponential growth problem. If you think about it, in a compound interest problem, whether or not it's compounded a finite number of times per year or continuously, you are constantly making money off of your interest that you're earning that year as well as your principal investment. So if I have this interest formula and it's compounded quarterly, that means the first time you get interest that year, it's based off of your principal investment, which is this initial amount. But then the second time, it's based off of my principal plus the interest I made that first time. And then that grows. So again, when I go to get interest the third time, it is based off of a greater total amount because I've made interest twice already. So it's better to get some sort of an investment where your interest is being compounded either a greater number of times, so n is bigger than 1, or continuously. So if we take a look at these examples down here, the first one, I have $10,000 to invest at 5% over a 20-year period. How much money would you have if interest is compounded semi-annually, monthly, daily, and continuously? So first, semi-annually, that means n is 2. So, So we have a of t equals my initial investment, 1 plus my rate over the number of times I'm getting interest that year to the 2t. So now I want to find how much is after 20 years, so I'm finding a of 20. So that's 10,000, 1 plus 0.05 over 2 to the 40. And that would give me $26,850.64. If I did this, but I did it monthly, it would be the same, but I'm going to replace those two 2's with 12. So a of 20 would be 10,000, 1 plus my rate over 12 to the 12 times 20, so 240. And that gives me $27,126.40. Daily, now that n is 365, we don't have to get hung up on if it's a leap year or not. So 1 plus my rate over 365 to the 365 times 20. And that is going to give me 27,180 and 96 cents. And then finally we have continuously. So we have my initial amount times e to the rate times my time. And that is $27,182.82. So you can see the more times it's compounded per year, the closer it gets to my amount for compounded continuously. So it makes sense that your best investment at the same rate would be to go with compounded continuously because you're continuously making money off of your principal and the interest that you're gaining. So I'm going to skip over 2. I'm going to have you try that one out on your own. So press pause for a second and then press play when you're ready to see the answers. Okay, so you can see what we get here, and you can see the daily is really close to the continuously amount. So in the next example, we don't have the same rate. So plan A, we have $4,000 to invest at 6% compounded annually. So compounded annually, the n is just 1. So that's sort of like my exponential growth function. So it would be 4,000 and then 1 plus my rate over 1 to the 1t. So that's just exponential growth. So when I go and plug in my 10 for the number of years, we have 1.05, oops, sorry, not 5, 6 to the 10th. So that will give us $7,163.39. The next one is compounded, oh, I wanted to do continuously, I'm sorry, continuously. So let's do this one continuously. A of t equals 4,000 to the times e to the rate times 10. So I should go, this is a of 10, not a of t. So that gives me $6,933.01. So plan A would be the better choice if it's only over a 10-year period. Then finally it says, after how many years will the investor have $5,000 if they choose to invest at 6% compounded annually? So I'm taking this formula from up in plan A, and I want to figure out when my amount is 5,000. So I'm going to divide both sides by 4,000. And then I'll have to take the log of both sides. So we get the log of 5/4 equals t log 1.06. And I'll divide both sides by the log of 1.06. So t equals the log of 5/4 over the log of 1.06. This is my calculator ready answer. And then I'll round my final answer, 3.83 years. One last thing I wanted to point out before you get going on some of these examples is something like number 6. So just so you are aware, some of these problems will ask for something like 2 years and 3 months from now. You want to look here at the amount that your car is depreciating is per year. So your time unit will be in years. So you may need to use some fractions in your exponents when you evaluate something like this. So 2 years and 3 months would be 2.25 years. So just keep that in mind when you're doing some of these problems. Classwork.